All right, this is section 1.3. This is the last example, question 8. It says a 100 milliliter of a 1.0 molar potassium phosphate is mixed with 100 milliliters of 1.0 molar silver nitrate, and it forms a precipitate. It says list the ions that remain in solution in increasing concentration. So the first thing we want to do is probably figure out moles based on each of these. So for potassium phosphate, we have 100 milliliters of 1.0 molar. So if we want moles, which is M, 100 milliliters, and it is 1.0 molar, which is moles per liter. And we have milliliters here, so I'm going to write it as 1,000 milliliters rather than 1 liter. And so we have 0.100 moles of K3PO4. The silver nitrate has the same volume and the same concentration, so we could say that this one has the same number of moles, and that's silver nitrate. So here's what's happening. A solution of potassium phosphate plus a solution of silver nitrate reacts, and it says it forms a precipitate. First, we're going to have to figure out what the two products are. So the potassium and the nitrate will combine, and the silver and the phosphate will combine. So we're going to have something with silver and phosphate. In order to figure out the ratios of this formula unit, we need to know the charges. So based on this, charge of silver is +1, and phosphate is -3. And so if you were going to make this a neutral compound, you would need 3 silvers to make it neutral. And we don't know what the state is yet. I'm just going to put parentheses and then move on to the next one. The next compound is something between potassium and nitrate. Potassium is an alkali metal. It has a charge of +1. Nitrate has a charge of -1. So that means that it's already a neutrally charged compound here. It's just one of each. KNO3 is the formula. And I'll leave room for a state here too. Now there are solubility rules, and there's quite a few of them, but here are a few that I know for sure. Nitrates are almost always soluble. And the same thing, alkali metals are in general almost always soluble. So with these two things together, I would expect this to be dissolved in water as an aqueous compound, which means that my precipitate is probably going to be this silver phosphate. So we'll say that's our solid. Now we have to make sure that this equation is balanced, and as it is written, it's not balanced. So quick balancing, I see I have 3 potassiums in the reactants and 1 in the products. Put in a 3. So now I have 3 nitrates in the products and I have 1 in the reactants. Put a 3. That makes 3 silvers. I have 3 silvers here. And at this point we're balanced and ready to move on. So we're going to make one of these tables, initial, change, and final. And we're going to start with the numbers that we calculated. So potassium phosphate, 0.100 moles. silver nitrate, 0.100 moles, and we, at the beginning of this reaction, have none of these products. The change. Now, the change depends on which one of these two compounds is the limiting reactant. And there are several different ways you could calculate the limiting reactant, but here's how I'm going to look at it, just for simplicity this time around. We have equal amounts of the reactants. For every one of these, we need 3 of these, which means that these are going to run out first because we're using them 3 times faster. If we used 100 of these, we've only used 33 of these. And that's how it's going to work. So over here, we see that for every one of these potassium phosphates, we make 1 of these silver phosphates. So we're going to have plus 0.33 moles. And for every 3 silver nitrates, we make 3 potassium nitrates. That one's going to be plus 0.100 moles. For a more in-depth look at how I did all this, you might come talk to me in class, or I could probably make another video if requested. But for now, to keep this video short, I'm just going to keep moving along. So at the final, we have 0.067 moles of K3PO4. We have no more silver nitrate because we used it all. This would be our limiting reactant. So with the silver phosphate, we had none. We added 0.033. Now we have this much. And for the potassium nitrate, we now have plus 0.100 moles. So these are our final concentrations. The question is asking us something odd. List the ions that remain in the solution in increasing concentration. So we have to figure out the concentration of each of these ions that are left. So we need to know concentration of potassium. We need to know concentration of phosphate. We need to know concentration of silver. And we need to know the concentration of nitrate. So we're going to have to find each of these 4 things and then arrange them. So for the potassium, we have some potassium here in the reactants, and we also have some potassium here in the products. So here our final concentration is 0.067 moles of K3PO4. If you look at this, there are 3 potassium ions there. So you have 3 ions times the number of moles. This is the potassium number of moles just here. Then we have to add in our 0.100 moles of potassium in the products. And so we end up with 0.300 moles. For the phosphate, so here's what we have. We have 0.67 moles of phosphate ions in the reactants, and it's just 0.67 because there's only one phosphate in this compound. And do we have any in the reactants? And actually no, because the only place we have phosphate in the products is in a solid, so it is no longer in the solution. And so this would be the number of moles of the phosphate ion. Silver plus silver. So we have no silver ions left over here, and all of the silver in the products is in a solid, so there are 0 moles here. Lastly, we have nitrate, and we have no nitrate left in the reactants. All of it was used up. And in the products, we do have some nitrate. We have 0.1 moles of it, and there's only one nitrate per compound, so it's just going to be 0.1 moles. I'm going to leave this in terms of moles because these are all in the same solution. There is 200 milliliters of solution here. So I could change it to concentration, but right now I just have it in terms of moles. Actually, I do have it in terms of the brackets, so I should change it to moles. So divided by 200 milliliters, which is 0.2 liters. Do that for all of them. This will just be 0 molar. So we have 0.3 divided by 0.2. This is 1.5 molar for the potassium ion concentration. Here we have 0.335 molar for the phosphate, 0 for the silver, and 0.5 molar for the nitrate. So looking at our concentrations in terms of increasing concentration, silver would be the least. There is no silver here. Next would be followed by phosphate, followed after that by nitrate, and then finally by the potassium ion at 1.5. That's its concentration, potassium. And this would be your increasing concentration.